Okay, so I gave a Google Doc for what we're going to do here. And so for each of these 5 sequences of numbers, there's going to be a pattern, and I'm asking you, what do you think the next number in the pattern would be given the sequence of numbers that you've already been given? All right. And where am I going? Going here. So on the class task, I went ahead and gave you a Google Doc. So that way you can just type this in and then just put a little explanation behind your reasoning. Okay, so let you guys work on this for a moment. I'll come in and provide some assistance shortly. But right now, this is what you're working on. So based upon the pattern that you see, what do you think the next number in the sequence is going to be? Okay, so we got this first one. Anyone want to volunteer what they think this first one's going to be? Anyone want to volunteer? Okay, Jorge, what you got? Jorge?
For number 1, I got 17.
Okay, how'd you get 17?
Because it went +1, +2, +3, +4. So the only thing that would make sense if it would be +5.
Perfect. Okay, you guys heard that. Got nothing to say. All right, so we'll look at part B in a moment. Okay, anyone want to volunteer what they think the number is for sequence B?
Is it 7?
Okay, so why do you think it's 7? It is, yes.
Because every odd number is 1 less than the number before. I mean, every even number is.
Okay. Now there's a couple odds and evens here, so I'm not quite sure what you meant, but you did get it correct. Notice it goes -1, +2, -1, +2, -1, +2, -1. Okay, so I think what Jaden was trying to say, if we went ahead and labeled the positions, this would be the first number, the second number, the third number, the fourth number, the fifth number, the sixth number, the seventh number, and we're looking for the 8th number. Okay, so if we're trying to get an even position, we subtract 1. If we're trying to get an odd position, we add 2. I think that's what you were trying to say. But so notice we can state this pattern a lot easier if we numbered the position of the numbers in the sequence. Okay, then we got this last one. Or not the last one, but C. Anyone want to state what they think that next value is for C? Any volunteers?
-1.
Okay, why do you think it's -1?
Because it goes 1, -1, 1, -1, 1, -1.
Right. Okay, so if we label these by positions, notice every even position is -1. Every odd position is +1. Okay, so there's actual rules we can rate for these. They're a little complicated, so I'm not going to go there. But it's easier to make a rule if we label the positions using whole numbers. The first number, the second number, the third number, the fourth number, the fifth number, the sixth number. Okay. And so we got this part D problem. All right. So we got the part D problem, then we got the part E problem, then we got the part F problem. So let me write that on the board and then we'll finish. Okay, so anyone want to volunteer what they think the number is for sequence D? Any volunteers?
Would it be
13.
13. Okay, notice this is a linear pattern because we're always going up by 2. We're always adding 2. A was not, because what we added to the previous number changed. It went up. D is. Okay. All right, what about E? Anyone want to volunteer what they think the next number in the sequence is? What would be the next fraction? I'm going to call on somebody now. All right. So what would be the next fraction? Let me, again, I could just call randomly on somebody, but I prefer them be fair and use my random person picker, at least because that's fair. Miss Bollock, what do you think the next fraction is? Miss Bollock or Miss Bollock? Sorry. Ariel, B. What do you think the next fraction is?
Would it be 1/5?
Mm-hmm. Yep. So sometimes some patterns in like C, right, and E is probably less demanding. Some patterns are less demanding. So yeah, that would be 1/5. Okay, and then we got the last sequence. Okay, the last sequence. Anyone want to state what the last number in sequence F is? And, or at least state, what do you think we're doing as we're going to the right? Correct, Peyton. Yeah, we're multiplying by what? What are we multiplying as we go to the right? That's right. Yep, we're multiplying by 3. So we just multiply the previous number by 3. Okay, these are called sequences. And sequences are extremely important in the sciences because they model real world phenomena very well. And the way we make rules for them is by numbering the position of the sequence numbers. That's how we can make rules for them. And then we just apply the rule to the position number. Now, you might remember we had some picture numbers, right? So starting with 3, The first time we add 2 is to get the second number. The second time we add 2 is to get the third number. So we could say 3 plus 2. Why am I doing n minus 1? Because if n is 2, that's the first time we added 2. And this one's a little easier because notice this 1/2 is the second number, 1/3 is the third number. So this rule we could just say is 1 over n. In this rule, right, the second number is the first time we added, multiplied 3. So we're starting at 10, and then we begin to multiply 3, and then I'll use an exponent n minus 1, because when n is 2, that's the first time we multiplied the 3. Okay, we're going to come back after a break, and we're going to look at these type of sequences. Okay,